Hi, today I'm going to talk about a math problem that's very interesting, and I will first solve it using traditional math techniques, and then I will let a computer solve this problem using SMT Solver Z3. Okay, so let's get straight into the problem. The problem is problem number 79. A trucking company has to move 844 refrigerators. So there are 844 refrigerators that must be moved from one place to another place. There are two types of trucks it can use. One that carries 28 refrigerators, another that carries 34 refrigerators. Okay. If it only sends full trucks, I mean, you cannot send a truck with half filled. That's basically what it is. And all the trucks have to return empty. List the possible ways of moving all the refrigerators, say from place A to place B. Okay. So the problem is you have to move 844 refrigerators from place A to place B. And there are only two types of trucks. One can carry 28, another can carry 34. So how many ways they can transfer all the 844 refrigerators? That's basically it. Okay, and you have to list the possible ways. So first of all, we can model this problem using the linear Diophantine equation. Very simple. Let's do that quickly. Okay, so the way we will do it is let's take a simple approach. Let's say we have 28, one that can take 28. Let me clean this one moment. Okay, so we have to transfer 844 refrigerators from place A to place B, right? That's the goal. And we have two types of trucks. One truck that can carry truck 1, or let's call it truck X, okay? That can carry how many at a time? 28, okay, refrigerators at a time. Okay. The truck Y can carry how many did I say? 34 at a time. Okay. All right. So how do we now transfer all the 844 refrigerators from one place to another place? So we can model it is as simple as this, right? We could say 28x, because in each trip we can put 28 refrigerators, okay, and 34y is equal to 844. That's basically the equation we want to solve. This is a linear equation, right? This is called the linear Diophantine equation, right? Very historical from a linear arithmetic perspective, right? This is the linear Diophantine structure, okay, or equation. All right, so we know that such an equation usually has either no solution or infinite number of solutions. But in this case, we are looking for x and y to be greater than or equal to 0. Otherwise, it makes no sense, right? To say a negative number of trucks doesn't make sense. So in that case, we must be able to list all possible ways we can transfer all the 844 refrigerators from place A to place B. So this problem can be solved using linear Diophantine equation tricks. First of all, we can rewrite this problem in a much simpler problem, right? We can just divide it by 2 on both sides to make it simple first. We could say this is nothing but 14x plus 17y is equal to, how much is this? 422, right? Okay, so this is the problem we wanted to solve. Is the equivalent problem. Equation number 1 is same as equation number 2. Before we solve this, we will solve a different problem. That's the trick. The trick is that we can actually solve first 14x plus 17y equal to 1, and then we will be able to go to 422. Okay. Is 14x plus 17y equal to 2? Can it be solvable? We can just try different x and y manually. I have already tried in paper, so I will just say when x is equal to minus 6, y is equal to 5, you get the solution. you can check for yourself. Minus 14 times 6 is 84, right? Minus 84. And 17 times y is 85. Therefore, you get answer 1. Okay. How did I get this minus 6 and 5? I just guessed it, but you can also use extended Euclidean algorithm. Okay. Extended Euclidean algorithm to solve this particular part of the problem. Okay. Extended Euclidean algorithm. Okay. Once you find this x and y, we can now go back to the original problem and think about the right hand side now. The right hand side we have is not 1, we have to solve for 422, right? So what it means is that we can say our x must be then, with respect to the original problem, our x is minus 6 times 422. It makes sense because we're just multiplying both sides by 422, right? Let me give you some time to think about why am I multiplying x by minus x by 422, because we solved 14x plus 17y equal to 1, which means if you want to get the right hand side to be 422, we need to multiply each side by 422. That's basically what I'm doing. So this is basically the solution for my original equation that I wanted to solve. This solution, this particular problem is the problem we have to solve, right? Okay, so but if you look at it carefully, x is negative, which makes no sense in this context. Now comes the linear Diophantine equation sum of the properties. Okay, so whenever you have a equation like ax plus by equal to c, either it has no solution or infinite number of solutions. So we found one solution, that means there must be more solutions. Okay, so what are the other solutions? What type of structure do other solutions take? The other solutions have this nice structure. Okay, let me write that structure for you. The other structure is, other solutions is this: x is equal to minus 6 times 422, exactly the one that I wrote it for you, plus, okay, plus some number n, we don't know what the n is at this point, I will explain that, times 17. Okay, basically you take the component here attached to y and plug it in. Since the right hand side is 1, which is true for 14 and 17, they don't have any common factor, right? GCD of 14 and 17 is 1. We don't have to one moment. We don't have to divide it by GCD because dividing by 1 makes no sense. Otherwise, you would be dividing it by GCD here. Okay, so I will put it 1 for learning purpose when you generalize it to other applications. Okay, anyway, so here is the x. And what about y? Okay, the y is also simple. It is 5 times 422. Okay, plus, now it's not plus. Okay, it's minus n times 14. Okay, again I will be dividing it by 1, but you have to divide it by GCD of a and b. Okay, a is 14, b is 17. Okay, so why is this other solution? Well, what we are doing is, if you go and plug this number x to this equation here, what will happen is basically you're multiplying 14 by n times 17. And then the next part, you're multiplying 17 by n times 14, the minus in front, so they will cancel out. So that means you can now put n equal to 0 as one solution, n equal to 1 as another solution. So you get multiple solutions when you try for different values of x, different values of n. For each value of n, you get a value of x. For each value of n, you get a value of y. Okay. So far, this is the generalization. Okay. But in this case, we are interested in x and y to be greater than or equal to 0, right? So which means that our minus 6 times 42 plus 422 plus n times 17 is better to be greater than 0 or equal to 0 because we only want positive or non-negative values, right? Okay. So let's rewrite this these two components now. Okay. So what it means is that our n times 17 be greater than 2532. When you multiply 4 into 6 into 422, the value is 2532. Okay, which means n be greater than n better be greater than when I divide it, it was like 148 decimal something. The That means since I said n is an integer, the value of n be better than or equal to 149. Okay, this is coming from x being greater than or equal to 0. Similarly, when you add a constraint that y is also greater than or equal to 0, you will have another equation that is like this. N from this coming from here, right? Just to be clear. And now I'm going to write something from the y part. Y must also be greater than or equal to 0, right? That means 5 times 422 minus n times 14 be better than greater than or equal to 0, which comes to be an n less than or equal to, well, n is strictly less than 150. Okay, so dot something, okay, some decimal number 7. So which means we can just say n less than 151 because n is integer. Okay, what are the possible values for n now? Either n can be 149 or 150. So there are two solutions. So here is the possibility. Our n cannot be other than 149 or 150. These are the only two solutions possible. Okay, so if you plug n equal to 149 over here, what will be the x when you plug n equal to 149? You get an x which is 1 and y to be 24. Okay, when n is 149. Okay, this is when n is 149. Okay, this is one solution. When n is 150, you get another solution. Okay, which I'm not going to write. You can just plug in 150 here for both x and at the place of y, and then you will be able to solve it to find the other solution. Okay, that's basically the approach I manually pursued, right? Wrote a linear Diophantine equation and then found out the possible solutions. There are only two possible ways the truck company can transfer all the trucks from one place to another place using these two trucks. Okay, so it means it will use truck number x to carry either 28 refrigerator, and then it will use truck number y 24 times to carry 34 trucks, 34 refrigerator each time. Okay, or the other solution is when you put n equal to 150, you should be able to find other pairs of x and y. Okay, so now let's use a computer to solve this puzzle for us instead of we doing it manually with all of the extended Euclidean algorithm and linear Diophantine equation. Let's solve it mechanically. Okay, so I'm going to do that part now. What I'm going to do is now going to share with you my simple solution to this problem that I will automatically solve using SMT Solver. Okay. So the SMT Solver, I have codified the same thing that you are seeing on the whiteboard here in SMT syntax. So Z3 is the solver that you can get it from the internet. It's a nice solver. I declared two variables x and y symbolic, and I need a solver object that will solve the constraint. The constraint is 28x plus 34y must be 844, and we are seeking x to be greater than or equal to 0, y to be greater than or equal to 0. So in SMT Solver, this is the syntax to add your constraints, and then you're asking the solver check for some solution. If there's a satisfied solution, ask for the model. Model means the actual values of x and y that satisfies these two constraints, and then we print those model, and then we continue to ask the SMT Solver, are there any other solution other than the x and y you just printed? So you say, don't show me the same x and y, show me anything else. So it's going to continue until the solution becomes unsatisfiable. That at the time it will stop. Okay, so let's compile this and run it, right? Well, it's Python, so we'll directly run it, and hopefully we will be able to see two solutions. Okay, so solution number 1 is 18 and 20, and solution number 2 is 1 and 24. That's basically it. It's much simpler to of course codify the constraints in ZMT. It's a Z3 solver, and let us SMT Solver solve this for us. Okay, let me explain this. What's happening here? These are the constraints coming directly from the problem statement. We ask the solver to find a satisfiable a solution that will, when assigned to these two equations, we have a good solution. And then we tell the SMT solver to find other solutions other than the one that was printed. It will continue to do so until it reaches the place where the solution is no longer satisfied, that it cannot find any satisfiable solution. Then we stop. Okay, that's all. Thank you very much.